The final topic for classes and objects is about helper methods. Let's just use one slide to summarize about what helper methods are really meant for, the motivating scenario, and then I'll give you 3 examples to really go from one version without helper methods to an improved version of your code with the helper methods. I'll do 3 examples together with you on Eclipse. It's more like a mini tutorial for this part of the lecture. Let's see. It's really important to realize after you have complete and also you have tested your program, presumably using JUnit tests, feeling confident that your code is simply just correct. Maybe you pass all the JUnit tests, and also you have written additional test cases, and then you pass them all as well. However, you might find that there are lots of repetitions of your code. Maybe the same fragment of code simply appears more than one places in your code, maybe even in multiple classes. So this might match the experience of many of you. If that's the case, I think that's simply just normal. I think you're really hitting some bottleneck to really become a better programmer. Let's now talk about the principle for helper methods. First of all, let's understand why, without using helper methods and you simply got repetitions, why would it be bad? So when similar fragment of code appear in your program, so developers like to say your code actually smells, which means it's not as nice as it could be without when you actually don't have any repetition. So people like to say your code simply smells. Exactly why it would be bad, it will involve a little bit more principle about software design. It's something called single choice principle. If you're interested, you can ask me in the Q&A, or you can drop by my office hour. I can explain a little bit more to you. Otherwise, you will learn about it, hopefully, ultimately, in your maybe 3rd year software design course. But for now, you just have to know, every time you see any repetition in your code, it's definitely a bad sign, and we can say your code actually smells. And we may eliminate repetitions of your code by, we say, factoring out recurring code fragment into a new method. Basically, identify where this common piece of code actually appears in multiple places in your code, and try to put this piece of common code into a separate helper method. And then, how would you do with the existing repetition? You want to replace, of course, the new method is called a helper method, and you want to replace every occurrence of the recurring code by calling this helper method. That's the principle, right? You can see the principle is really easy, but it's really about how you can really apply your creativity to really create helper methods. I would say it's really hard to teach this, but I can only teach you in principle and also give you some examples. And then it's really up to your experience building as a programmer. And so we want to reuse the body implementation rather than just repeating it over and over again. And let's recall the very definition for a method is simply a reusable named block of code, right? Remember, that's what we said previously in this lecture number, in this classes and objects lecture. And one thing to also emphasize, the idea about helper methods is not just specific to OOP. So even if you do procedural programming or even later functional programming or logical programming, the idea about helper methods or helper functions is all applicable throughout your programming paradigm. So, but for OOP, we can just study specifically about maybe context object, right? We'll see examples in that. And the process is really called refactoring your code. So when people talk about refactoring, so what do they really mean? So they mean the following definition. So whenever you want to refactor your code, for example, you may want to rename the methods, you want to rename the class, or you want to create helper methods and replace every occurrence of repetition by helper method call. So these are all examples for refactoring. So to refactor your code means to modify the code structure, internal structure, without compromising correctness. So let me emphasize again, correctness is the number one important priority, the only priority you should really achieve, for sure. If your code is simply not correct, it doesn't really matter how efficient or how effective your code has been developed. It doesn't really matter if it's not producing the right output. So correctness is always a number one key. But given that it's correct, you can then think about how to refactor your code by factoring out all the recurring code fragment or by eliminating the smells of your code. Right? That's a principle I'd like to mention in one slide. All right, so now let's talk about 3 examples for going from the version with lots of repetitions to the version without the repetitions using a helper method. Let's do 3 examples together. Let's see the first one. Okay, that's something we are very familiar with. Let's say person collector. So we got our array of person, we got our maximum capacity, and also we got a counter over here. Right, that's something we are very familiar with. And then we got person collector constructor, and also we got a mutator to add a person objects to the end of the array. And also, okay, that's it. Right, it's very simple class. And let's say we want to complete the following three tasks over here. Number one, we want to define the accessor returning a Boolean value. Just try to tell if the person actually exists with in the person collector. For example, if person Hyang actually exists in your store person objects. And of course, we assume that for every person, we have an attribute called name. And also, we got a public accessor get name to return the name of the person objects. And then we got a mutator. Let's say change the weight of. We want to search through the person collector, and then we want to identify a particular person with the input parameter name. And then we want to modify their weights to the input. And similarly, we also want to change the height of a particular person. And of course, if the person doesn't really exist in the person collector, let's say for now, for the purpose of illustration, we simply just do nothing, right? If you want to change the height for Alan, but Alan doesn't really exist in your context object person collector, in that case, you just don't do anything to modify the person collector. Okay, let's look at the version without the helper method, meaning that we got lots of repetition. Let's see. Let's say we got person collector. So here I'm just omitting all the attributes and methods and constructor I just spoke about. And then let's say we got one accessor method here. Simply check to see if a particular person exists. And for this one here, it's more like an existential property we are checking. So we have to initialize to see if we have found the person yet. Okay? But here I'm just giving you the version. It's like a version 1 without early exit. You can definitely revise it if you wish, but that'll be good enough for illustration. So we run the loop over here, and the upper bound should be NOP, and then we want to say if the current person objects in the collector we are looking at, if their name is the same as the input name n over here, and then we're gonna set the found to be true, and then eventually we just want to return whether or not found is true. So this will tell us whether or not the person exists in the collector. That's the first method. Second one. Let's say we want to change the weights of a particular person. We're going to do a very similar process over here. We still want to go over the entire array up to NOP, and then we want to see as soon as we see if the current person's name is equal to the one we're looking for. In that case, we're going to set their weights to be the input weights, and we're assuming that the set weights is actually some mutator that's defined in the person class. You will see that when you import the lecture projects. Finally, we got change the height of will be very similar, except that once we find the matching person with the matching name, and then we're going to change the height, right? So now, without me showing you any annotation, you can see there's a lot of duplication about the loop structure over here. The duplication really is we are always going to here is the recurring repetition in this class over here. So we actually for every one of them we have to write this particular loop header, and also we want to find this particular matching person, and then of course whatever we do inside might be a little bit different, but what's really repeating is about the code structure of finding the match inside the array. To be more visual, you can see these are the yellow highlights really show you the duplicates of the code, right? So hopefully you can see that. So now make sure you really understand what the problem is, and now I'm going to move on to Eclipse to really try to define a helper method, and then replace every occurrence of the repetition by the call to the helper method, so I can eliminate the smell of your code. That'll be about the first example. Let me just, before once I go to Eclipse, I will program the helper method right away. So what should I do for the helper method? So the common repetition over here, you can see the yellow over here, is really about given some name over here, I want to somehow find out some matching person in the array, in the person's array, right? And then I will want to do something about it. You can see this part here is different from this part here, and also it's different from this part over here. So to really find a match, finding a match will really be the common part. So let's say if I want to find a match, I can simply say, okay, I can either say I want to return the person objects that actually has the matching name. So this is actually what you did in your week number 8 tutorial videos. That's what you can review it. I'm gonna do something different. What I can return, rather than a person object, I can return the index of the matching person. And then once I got the index, I can actually apply that particular helper method to each one of them. Right? That's kind of my design decision to share with you. All right, let's now move back to Eclipse over here. And then you can see under your lecture number 4, classes and objects projects, you can simply go under helper methods and go to person collector. And the person collector is using the person class inside this OOP package, which we spoke about in the earlier weeks. Okay, you can look at it. Let me maximize this, and then let me now try to program that directly, right? So you can see lots of repetition at the moment. You know, to really show you the difference over here, I would suggest person collector. Let me copy that, and then let me paste it. Let me give a new name. So what about person collector improved? Okay, or you can say person collector with helper method. It's up to you. But let me just say improved. So I can still leave the old version over there, right? Let me close this one here, and then open that. All right, let me now define the helper method. Typically, helper methods are only for internal use, so you can simply declare that as private, meaning that from other class other than person collector improved, they just cannot get access to this helper method. Okay, typically that's the case. But let me go back here, and then let me make some more space, so I'm now in the middle of the screen. So I'm gonna say this. So we're gonna say return the index of person with matching name, right? You can see basically for every of the method I want to improve, they all pass the name of a person over here. So this will be also the input parameter for the helper method, right? Let's now say private integer, and then I can say index of person over here. And then I'm gonna use just the same input parameter over here, right? Copy and paste. Okay, and let me give a little bit more description over here. If actually, what the previous description is pretty nice, but I just need to say the other case. What if the person does not exist? Return -1 if no person in the array. When I say array, I meant the PS array over here. That's what I meant. Okay, in the array, PS has the matching name. Right. So we got two cases over here. So let me just go right away to the solution. So you have done loops in array extensively already. So I can now just do it. Integer I will be index to be returned initially -1. Return just I. So what I'm gonna write in the middle is I want to see if I should really reassign I to be some valid index. If somehow I don't really have any chance to reassign I to be something else, so that means it will just return -1. So this will effectively match the second case over here. So I'm simply just going to, you know what? Let me just show you. I can simply just copy one of the repetition. I'll simply put it here. Okay. And then let me say rather than I, let me say index over here. Like that. Okay, and then I'm just gonna say I'm gonna use this one here, still the same, and then so this will match. If that matches, I'm simply just gonna know I need to reassign the index to be the current value of I. That's it. That's the helper method. You can see the reason that I simply just want to copy and paste over here just to show you that I'm just reusing the repetition only once in the helper method. And now from now on, whenever I want to use that particular fragment of code, I can just refer to the helper method by calling it. Let's try. So what I will do, let me start from this one here. Okay. So what I can do is I can say for this one here, actually it'll be pretty easy. I can simply say integer index is assigned to index of person n, right? And if you like, I can also say this, right, implicitly. And then what should be the result? Result should be whether index is larger than or equal to 0 or not, right? If index is larger than or equal to 0, so that means we actually had a chance to reassign the index return value to be the I that actually has the matching person's name. Otherwise, it's going to be -1. And -1 is actually going to -1 is going to make larger than or equal to 0 false. So you also return false accordingly. So this is working. What about the second one? For the second one over here, we just want to set. Once we find the index, we can index into the person's array to get a corresponding person, and then we can actually set their weights, right? So I would suggest this. Integer index is assigned to this index of person, right? Pretty much similar to the very first line. And then we have already reused the code of the helper method. So now let's try to do the next. We can say if index is actually larger than or equal to 0, so that would suggest the index suggests some valid index into the array. So here I can simply say this ps the array and index set weights to be w. Right? I'm doing this conditionally only when the index that's returned is actually a valid index, which is not -1. If it is not -1, so that would mean the name over here can really locate some valid index for the person. And I don't really need to type much from scratch. I can simply paste over here. And rather than set weights, I'm going to say set height. And h. All right, so that's about this improved version, right? So you can really take that as a case study. I define the helper method, and then I replace the a repetition by just a call to the helper method. You can see 1, and also 2, and also 3. You can see the same loop structure that has been repeated over 3 times in the unimproved version has now been improved. So only one occurrence. And the more you actually use this helper method, the more you're really potentially eliminating lots of duplicates. Hopefully you see that point. So that's the first example. Let's go on to the second one. The second example, so that's the final outcome. You can also see that from the slides, right? The second example is about also accessor. Okay, let's see this. Let's say we talk about 2-dimensional points. We got point with x and y, where we have seen that examples a lot already. Let's say we got one accessor, which is to say go to get a distance from the current point, the context point, from the origin, right? So if I say p dot get distance from origin without any parameter, it's going to return the distance between p, the context object, and the origin. Okay, that's the first method. The second method is also accessor returning double. It's gonna try to see the summation of the distances from, for example, if I say p dot get distances to p1 and p2, I want to see what's the summation of the distances from p to p1 and also p to p2. Sum up the two distances, right? So you can see that what's really being repeated is about how you calculate the distance between 2 points, right? Another one, let's say get try distances over here. Now, if I say p dot get distances to, so now I want to say I want to really call the following. I want to calculate what's the summation of p, the distance between p and p1, and also between p and also p2, and also between p1 and p2. Right, the 3 distances we want to sum them up together and return the value. So what's really being repeated over here conceptually is really about the formula to really calculate the distance between 2 points, which we have seen already, right? You gotta say x minus x, the 2x, and also plus y minus y squared, and then square root, something like that. Let's see the solution that smells. We got x and y, and also let's say the first one, we spoke about this definition already. You can think about math. We will only talk about your API for Java in the final 1 or 2 weeks. So for now, just treat the math as a utilities class, and SQRT stands for square root, and POW stands for power, right? So now this will be this dot x minus 0, the origin x to the power of 2. That's basically what it is doing, right? We'll speak about exactly how you use the math class in the final 1 or 2 weeks. But for now, just treat them as a utility methods, which you are familiar with for sure. Okay, so this one here is just about this dot x minus 0 to the power of 2 plus this dot y minus 0 to the power of 2, and then you take the square root. So that's applying the formula for the first time, repetition 1. And what about this? I want to calculate the summation of this the distances from this to P1 and also this to P2. So this part over here is really calculating distance from this to P1. So I can say this dot x and also, oh, this one should be this dot y, right? Implicitly, this dot y as well, right? And this will be P1 dot x, P1 dot y, and also P2 dot x, P2 dot y. So now you can see this is repetition number 2. And this is repetition number 3, right? Finally, for the try distances, right? We want to see what's the different distance between this and P1, and also between this and P2, and also between P1 and P2. So in total, we got 1, 2, 3, 4, 5, 6. We got 6 repetitions. So now what we can do is we can define a helper method. Excuse me. We can define a helper method to really factor out this particular formula coding over here about calculating the distance between any two arbitrary points, and then we can call this helper method exactly 6 times in the improved version. That's what we will do conceptually. All right, and you can definitely see the so that's exactly what I just said. So that will be the helper method I want to define. Let me just copy the header over here so I can save some typing. And then I'm just going to, so the parameter will be the x from the other points and also y from the other point. Alternatively, what you can do is you can simply declare point P, right? And then you can say P dot x, you can say P dot x and also P dot y alternatively. That's what you can do instead. Let's now move on to Eclipse. And then I'm just going to create another version for the points, right? This is the smell version, all right? Let me now just copy that. Let's say copy, and then I'm going to paste it. Let's say point improved over here. So that'll be the improved version I would like to see, okay? And then let me just maximize it, and then go all the way to the middle. Okay, so that's what I would like to, what I like to set up. And then let me simply just copy this header over here. So I want to define some private helper method, right? Helper method to return the distance between this and other, right? So when I say this, I mean the this in OOP, the context objects, right? Let's see how we can define this. What we can do is we're going to apply the formula. We're going to return math like utilities and then dot the square root of basically some addition. It's going to be something plus something over here, right? Actually, we want to do the square and plus the square. So over here we can say math dot power something to the power of 2, and then I'll replace the 8 in a moment, and also over here to the power of 2. And what should be the difference? It should be this dot x minus other x, and also we can put this dot y minus other y. All right, so that's what I want to do. Okay. And at the moment, it's simply the yellow highlight over here is simply saying that so far we haven't really used this private method just yet, but I will do that. So what I should do now is to really replace every one of them. So you can see this this part over here, this first repetition is about the distance between this and the origin, right? So what I can do is I can say distance will be this get distance from. So I can say from this to between this and also the origin. Okay, so that's what I can do. That's the first one. What about the second one? The second one, I want to see the distance between this to P1 and also this to P2, right? So I can say this dot get distance from over here and p1.x and also p1.y. And as I said before, if you like, you can also change the parameter over here to be just a single point object if you wish. That will work as well. I'll leave that as an exercise for you. And similarly, I can also say over here, this dot get distance from p2.x and also p2.y. All right, so that's, you can see so far I have replaced 1, 2, and 3. 3 repetitions. Let's do another 3, all right? You pretty much know what I'm doing here, I'm sure. So let's say this one here is about between this and also P1, right? So why don't I just copy this and P1. And this line will be from this and also P2. And the final one will be from P1 to P2. So what I can say is, I can say P1 dot get distance from, over here, I can say P2 dot x and also P2 dot y. You can see it's really interesting here. Let's see this. Oh, of course, I don't need a semicolon here. Let's now understand this. I think that might be worth noting. We're calling this get distance from method from that's defined in the point improved, right? And then in this particular class. And you can see here it's simply the point improved over here. And then what we want to do now is to really calculate the distance, the distance between 2 points. And you can see the context object here, in this case, is simply this. So that means if you, let me just give you one example quickly. Let's say, for example, let's say if we try to do, let's say x dot, let's say x dot get try distances, and then I would say y and z. Let's say x and y, z are simply 3 different points. So in this case, every occurrence of this will be replaced by x. So this will boil down into x dot get distance from, and then y dot. So I'll just say y dot x. You know what? Maybe x, y, and z are not really good names. Why don't I say, is there a, b, and c? How about that? Yeah. So this will be a, right? You can see the context object is simply a. That replacing this. And then I can see point b dot x and also b dot y. Plus, and then we can see over here, that'll be, and then we will see a dot get distance from, and then from c over here, right? That's the context objects. C dot x and also c dot y. And finally, we can see here, the context object will be, for calling this method over here, will be P1. So what's P1 in this case? P1 is really argument 1, which is B. So that will be over here, B dot get distance from, and then C dot x and also C dot y, right? You can see the P2 over here really corresponding to the second argument, which is C. Right, so this is just one example to show you. Hopefully you don't really need me to go to iPad to illustrate this. It's rather simple. All right, so that's the second example to really go from the smell version to the, hopefully the version without the smell, using helper methods. Let's go back to the slides. One more example. Right, so that's exactly what I just illustrated. The final example will be just one small example about mutator. So helper method really doesn't really say whether it should be accessor or mutator. I would say either one. Even for constructor, you can also call a constructor as a helper constructor. So that's something we also spoke about in week number 8 tutorial videos. You can review it as well. Let's now talk about this particular class. We got students. So student got name and also balance. And when we first create the students, we'll initialize their name and balance. And let's say we want to define these mutators over here, right? Let's say we want to receive scholarship, in which case we'll deposit some amount into the students. And we want to pay the library overdue for the students. In that case, you gotta deduce the balance of the students. And also you may want to pay for the cafe coupons. And then you want to deduce some amount. And also you may want to transfer maybe from from one student to another student, and then with some amount, for example, right? They might kind of share their coupons and they want to share the balance. Let's see the small version with repetition. Let's see this. So receive scholarship will simply say balance, or you can say implicitly this dot balance. Balance increased by val, right? Also pay library overdue, you're gonna decrease it. And also you want to pay the cafe coupons, also decrease it. And also you want to transfer from one student to another, you will be basically reduce the balance for the current students, the implicit this, context objects. And also you're gonna increase the other students, right? You can see other over here will be incremented by its balance value. So here I'm making something that's not exactly good practice over here, but just for illustration. So here other the balance over here, balance should be declared as a private attribute, but since we're in the same class, so we can actually refer to the attribute using a dot notation directly. But if you're trying to use the private attributes, let me see this. Right, you can see the attribute balance over here is private. If you're trying to go from another class other than students, and you want to say dot balance, you will not be able to do it. But in the same class, you will be able to. Okay. So what's the repetition? You can see repetition is really about, you want to say balance is assigned to balance, and then it's really a matter of either plus or minus. So in this case, why don't we simply define two helper methods? One will be for increasing the balance, the other one for decreasing the balance. That's what we'll do. Okay, let me move on to Eclipse right away. This one's rather simple, but just worth illustrating. So what I will do is I'm going to say copy students and paste. Okay, students improved. Okay, let me go to the improved version over here. Okay, and I need two helper methods. Let me maximize it. So let me document it. Two helper mutator for incrementing and decrementing balances. Okay, let's do the incrementing one. Let's call it deposit. I can say private void deposit. If I want to deposit into the student's account, I can give double some value to deposit into. So what can I do? I can say this balance. So this is really the repeated pattern factor out to the helper method. Balance is assigned to this dot balance plus val. And then I'm gonna get another one for decrementing. Public void withdraw, and also double val. Okay, it will be very similar to this one here, except that I'll just say minus over here. All right, let's see how we can now replace every occurrence of the repetition by call to the helper method. So this one simply is just some with deposit, right? This dot deposit val, done. And this one here will be withdraw is minus this dot withdraw, and then val. Alternatively, if you like, you can simply say, rather than having two helper methods, you can simply say maybe set balance to be some value over here. Set. In that case, you can set it to be something smaller or set it to be something larger. It can also work. But for now, I just want to distinguish between deposit and withdraw. Let me go back here. And this one here will be about withdraw, right? This withdraw val. And this one, again, very similar to the point example, right? So this part here, to really call the helper method, I want to change the current objects, the context objects balance. So that I'm going to say this dot withdraw, and then I would say val. However, now I want to modify the balance for other, which is the input parameter. So now to call the helper method, other should now be the context object for calling the method. So I should say other dot deposit over here, val. So I would say this example is really easy, but I would say pay attention to when you call the helper method, you don't necessarily have to say this dot helper method always. You can also use the context objects, maybe from the input parameter, for example, that's of the same type. In this case, student improved, which is where the helper method was were declared. All right, So that's about the 3 examples I would like to speak about, but helper method is a very practical stuff for you to pick up. So I can only give you some principle and some examples, but it's really up to your experience of doing this. All right, so that's about the version I just spoke about, and we are done for the classes and objects. So it's been quite a intensive and extensive lecture about classes and objects, but hopefully the pace is not really too fast for you, and especially if you really try to supplement your lecture with the weekly Java tutorial videos, hopefully you can really grasp some solid foundation for OOP. All right, so we're going to move on to the next lecture series about two-dimensional arrays.